Hello everyone. In this video, we will see what is Euler's totient function or Euler's phi function. So Euler's phi function की जो डोमेन होती है वो होती है set of all natural numbers or set of all positive integers. So for us, z positive will denote the set of all positive integers or set of all natural numbers. So for any positive integer n, phi n क्या बताता है? Phi n counts the number of positive integers. So phi n counts number of positive integers which are strictly less than n and which are coprime to n, that is GCD of m with n should be 1. So phi n क्या करता है? Phi n counts the positive integers जो कि n से strictly छोटे हो और जो n से कोप्राइम हो. फॉर एग्जाम्पल अगर मैं n को 5 लूँ, ठीक है, सो phi n क्या होगा? Phi n will be 4. Why? Because these numbers, so 1, 2, 3, 4, these numbers, these are strictly less than 5 and their GCD with 5 is 1, right? So 5 will be 4. Similarly, if I take n equal to for instance 6, so ऐसे कौन कौन से नंबर है जो 6 से स्ट्रिक्टली छोटे हैं और 6 के साथ जिनका GCD 1 है? So these numbers are precisely 1, 5, right? So in this case 5, 6 is 2. So phi n क्या बताता है? Phi n counts the positive integers which are strictly less than n and relatively prime to n. Okay, now if we have any prime number, so suppose p is any prime number, then phi p will be, so phi p counts the number of integers, positive integers which are strictly less than p and whose GCD with p is 1. So see, we are taking p to be a prime number. So every integer, every positive integer which is strictly less than p is coprime to p. So this set will have exactly p minus 1 element, right? ये जो set है, set of all integers, positive integers which are strictly less than p and which are coprime to p, इसमें सिर्फ p minus 1 elements आएंगे, 1 to p minus 1. More generally, we have this formula phi of p raised to power a. This will be p raised to power a minus, where p is any prime number and a is any positive integer. We can write this as p raised to power a minus 1 times p minus 1. Now this function has a very interesting property. This function is multiplicative in the sense that phi of a times b, this will be phi a times phi b. So as you can see, we are using this Greek letter phi for this function, right? So this happens if A and B are coprime, that is GCD of A and B is 1. So this function has this multiplicative property. For example, if you have to calculate what is 515, then you know that 515 is what? 53 times 5, as 3 and 5 are coprime. And you know that 3 and 5 are prime number. So this quantity is 3 minus 1. This will be 5 minus 1. So it is 2 times 4, which is 8. So if you have a large number, so suppose you have any number, for instance, if n is any number, positive integer, then you know that you can write it as product of prime numbers. So for instance, I am writing n as product of these numbers. Then phi n will be same as phi of P1, A1 and so on up to PSES. Now this number and this second number P2 raised to power A2, these are coprime. Similarly, P2 raised to power A2 and P3 raised to power A3, these are coprime. So we can write it like this: P1 A1 times P2 A2 PSAS. This will be same as P1 A1 phi of P2 A2 P3 A3 and so on up to PSAS. So in a finite number of steps, what we will get that this will be same as phi of P1 A1 phi of P2 A2 phi of PSAS. So if you have any number, what you have to do, you have to write its prime factorization. Then you can easily calculate the Euler phi function by this formula, right? So for instance, and this will be P1 raised to power A1 minus 1 times P1 minus 1 and so on up to PS raised to power AS minus 1 times PS minus 1.